Welcome to This Explainer. Today, we are absolutely leveling up your game. We are diving deep into the Cambridge AS and A-level computer science syllabus, specifically focusing on course code 9618. We are here to master a topic that trips up countless students every single year: dynamic link library files, or DLLs, and their specific benefits to developers. Now, I want you to picture a real Cambridge computer science past paper question. We are talking high stakes. Let's look at two hypothetical students taking this exact exam. We'll call them Alex and Sam. Alex is the kind of student who overloads every answer with raw, unfiltered computer science facts. Alex just brain dumps everything they know about DLLs, but offers zero actual analysis of the scenario. Sam, on the other hand, is constantly rushing. Sam skims the question, completely misses the crucial command word requirements, and writes a vague, single-sentence answer. When the results come back, both of their papers are covered in red ink. Why? Because knowing the facts isn't enough anymore. You have to know how the examiners want those facts presented. If you've been looking for the ultimate guide to transforming those red marks into green check marks and cracking this exact portion of the exam, you are in the perfect place. Let's get started.
Okay, let's dive right into this. Did you know that DLL questions and their related system architecture concepts account for approximately 15% of the total marks in Paper 2? Think about that for a second. 15%? That is massive. In the context of the Cambridge grading system, that single percentage chunk can easily represent the difference of an entire grade boundary, or perhaps even two. A lot of you watching have already crushed your earlier exams. You've worked your way through syllabuses like 0417, 0478, 0983, 0984, or maybe 2210. You built a rock-solid foundation there. But 9618 is the big leagues. You simply cannot afford to gloss over the theoretical and practical applications of dynamic link library files here. It's not just a minor footnote, it is a major, load-bearing pillar of your exam success. Today's roadmap is structured to build your understanding step by step. We'll cover core principles, technical methodology, examiner warnings, and finally, your exam success blueprint. Section 1. Core Principles. The theoretical architecture of DLLs relies heavily on three core pillars. First, precise technical definitions. You need to accurately describe what a DLL is without being overly broad. Second, clear causal relationships. This means understanding exactly why a developer choosing to use a DLL results in specific outcomes. And third, integration with other syllabus areas. Now, this is where we fix Alex's problem. Alex just dumps facts. But top students use the PEEL framework: point, evidence, explanation, link. You make your point about DLLs. You provide evidence from the scenario. You provide your explanation of the technical mechanics. And then, crucially, you link it back to the specific constraints of the developer. If you can link the benefits of DLLs to broader concepts in system architecture using PEEL, you elevate your answer instantly. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Look at this core challenge. Why do students find interpreting complex binary representations so hard, particularly when it intersects with topics like DLLs and system memory? The answer usually isn't that the math is too difficult. Students struggle because they lack a connected understanding. They view binary operations, memory addresses, and dynamic linking as completely isolated boxes in their brain. They don't see the matrix, so to speak. They don't realize that a DLL is literally just a collection of compiled binary code sitting at specific memory addresses waiting to be called. So the crucial point is that to capture these marks, you must apply foundational concepts to completely new, unfamiliar developer scenarios. This was Sam's downfall. Sam rushed and missed the command words like evaluate or analyze. The examiners are not going to give you the exact same scenario you memorized from a textbook. They might give you a hypothetical game developer pushing the limits of system RAM, or a financial software engineer needing secure modular updates. Top students exhibit a conceptual understanding that acts like a universal toolkit. They take their core knowledge and seamlessly transfer it to whatever unique wild context the exam throws at them. Section 2. Technical Methodology. Pay super close attention here, because understanding the method mark strategy is your absolute safety net. This is how you secure partial credit even if your final code has a bug or your final calculation is off.
Examiners are explicitly looking for your process. If you are asked to solve a complex problem involving data structures or algorithmic thinking related to system files, showing your work is 100% non-negotiable. If you demonstrate the correct analytical pathway but make a minor execution error right at the finish line, this strategy ensures you still walk away with the lion's share of the points. Let's break down the exact procedural framework top candidates use to guarantee those method marks. Imagine you have 60 seconds to completely rewrite a flawed answer. Here is your mental checklist. First, you deconstruct the question. What is the command word? Is it identify, describe, or evaluate? Second, extract the relevant data from the developer scenario. Third, select an analytical framework, like the Peel method we talked about. Fourth, execute your analysis using crystal clear notation. And finally, present your answer using the correct terminology. If you follow these 5 steps, those red pen marks transform into green check marks right before your eyes. This brilliantly illustrates the systematic processing sequence required for algorithmic thinking. Look at the flow. You start with step-by-step decomposition, breaking the massive problem down into manageable chunks. Then you make your data structure selection. Next is efficient code implementation. But look really closely at that last row. Rigorous testing. You must verify your results and explicitly check edge cases. If you do not account for the boundary conditions where the system might completely break down, your algorithmic phase is fundamentally incomplete in the eyes of the examiner. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump straight into Section 3, Examiner Warnings. Welcome to our interactive workshop. I want you to imagine a complex system architecture chart on a test paper. You have a 60-second timer ticking down to scan it. What are you looking for? You are looking for the context. Take a look at these 2 approaches side by side. Let's find the flaw. On the left, a generic answer says, DLLs save memory. While true, it earns 0 marks because it is completely disconnected from the chart. Now notice the right side. It actually applies the concept to the problem. It says, by utilizing a DLL for the physics engine, the game developer ensures that multiple level modules can share the exact same executable code in main memory, significantly reducing the overall RAM footprint during runtime. That is a Peel paragraph in action. Point, evidence, explanation, link. That gets the marks. Let's make this crystal clear. Straight from the principal examiner reports, these are the top 3 ways students hemorrhage marks on this portion of the exam. Number 1, their answers are just too vague, completely locking the technical depth of the right side example we just looked at. Number 2, they totally forget to check and mention boundary conditions and edge cases. And number 3, the absolute most fatal mistake of all, their answers are completely divorced from the context given in the question. I want you to burn this examiner alert into your brain. Let me read it again. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. This is your speed writing challenge. If you only had 30 seconds to write an answer, your absolute priority is linking the concept to the scenario. Context is the undisputed king of 9618 paper 2. If the question is about a hospital database, your answer must revolve around patient data security and uptime. If it's about a gaming software update using DLLs to patch a bug without reinstalling the whole game, your answer must reflect that exact gaming scenario. Section 4. Exam Success Blueprints. Here's your final system. This is the complete computer science answering system that guarantees top marks if you follow its 3 golden rules. Rule 1. Command word decoding. You must know what the question is actually asking. Rule 2. Peel framework application. Structure your paragraphs with precision. And Rule 3. Time management matrix. Don't spend 20 minutes on a 4-mark question. Look at the pipeline here. Identify the information, break it down, solve systematically to get those method marks, check if your answer is actually reasonable in the real world, and make highly justified recommendations. Top-scoring candidates use this exact matrix to demonstrate high-level evaluative thinking when writing their final paragraphs. When a command word asks you to evaluate a developer's choice to use DLLs, you must consider multiple solutions to show your breadth of knowledge. You absolutely have to analyze the trade-offs to demonstrate critical thinking. Sure, DLLs save memory, but what about the risk of DLL hell, malicious injection, or versioning conflicts? You have to acknowledge those limitations to highlight system constraints. And always justify your final decisions with rock-solid, evidence-based reasoning. Let's recap. Context is king. Check your edge cases and secure those process marks. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acexams_IGCS and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing, keep applying that context, and I will see you in the next explainer.